So our next speaker is Dennis Wingo. I know Dennis by way of the Silomar Microcomputer Workshop. Who has attended a Silomar? Hey, we got a number of people here. Great. I've been on the committee for a number of years and made a lot of connections that way, and made a connection here with Dennis. And in fact, Dennis was found by one of the key members of the committee, John Wharton, who unfortunately passed away last year. But very nice to have Dennis with us. And so John Wharton is with us in spirit by way of you, Dennis. Yes. So Dennis is CEO and founder of SkyCorp and also Green Trail Energy, Inc. He's also co-founder and CTO of Orbital Recovery. He has extensive skills in solar electric propulsion, satellite and spacecraft design, advanced mission planning, and lunar surface operational scenario development. You can read his bio in your program. But one topic that I did not include there was the fact that Dennis restored and digitized the images of NASA's Lunar Orbiter program. And that's a whole interesting story unto itself. I also appreciate the fact that Dennis is connected with me with Seth Shostak, who'll be our interviewer tonight of Dr. Walker. And please welcome Dennis to the stage.
Green button. Well, thanks, folks, very, very much for having me here. I look out on the gray hairs here, and I wonder which of you I might have worked with in the 1980s in the computer industry up here as well as in Southern California. I want to thank all the old guys who helped bring us along and who helped mentor a lot of us young folks back in that era. So thanks very much. The time is now. Neil and Buzz landed on the moon in July of 1969. The last was my friend Harrison Schmitt in 1972. Who's upset that we haven't been back? All right, I agree. And my very first public speaking was in 1989 when it was 20 years after, and I was at this big NASA event, and I'm listening to them talking about going back to the moon, and it finally upset me so much, I got up and I asked the first question. I said, when are you people going to quit talking about it and let's go back to the moon? So that's the way I still feel today, and so I've dedicated my professional career since the 1980s in working with the moon. And so there is a lot of stuff that has happened since the 1980s in remote sensing of the moon. We know so much more. We know about the water. We know about the remote sensing that has confirmed many, many things about the moon that we didn't know before. So our goal is actually, and I work very closely with a lot of folks at NASA, NASA JSC, NASA headquarters, NASA Langley, NASA Ames. Our goal is actually the industrial development of the moon. And here at Texas Instruments, a lot of you folks work with vacuum, manufacturing chemical vapor deposition and vacuum. These are some of the technologies that we hope to bring to the moon. And with our remote sensing missions that we've had and the discovery, and let's call it confirmation in 2009 of billions of tons of water on the moon, we now have a lot of, let's call it the fundamentals for us to go back to the moon in force. But a lot of other tech that has been developed, like 3D printing, different additive manufacturing technologies, robotics, AI, machine learning, swarm robotics, all of this is going to take us back to the moon. This right here is my favorite area of the moon right now. NASA's talking about going to the South Pole, but this is the North Pole of the moon, where it's much more tractable for robotics, and we've done a lot of work in this. This is a times 10 exaggeration of Whipple, which is one of the crater next to the North Pole and one of the areas of permanent light on the moon, or near permanent light, about 89%. Sunshine, so we can do this with solar power. We don't have to wait for nuclear power. I did a design study just a few years ago showing with 1 megawatt of power, we get about 670 kilowatts average power a month, and that is plenty for us to begin the task of industrialization. This is the Whipple site details. It's the edge of a crater, and we know from the orbital missions, the Lunar Reconnaissance Orbiter that's there now, that this is the area that has the maximum light. There's a really cool program called Moon Trek. It's developed here at NASA Ames that allows us to do a lot of mission planning and a lot of surface operations, let's call it preparation, which we're still doing now. So the steps. This is not a science development. We are not going to the moon to recreate the Antarctic Research Station on the moon. We're going to use the moon, and we're going to industrialize the moon to build things, to do things to help us get to Mars. And as I say, I wrote a book about this in 2004. We go to Mars to take our civilization there. We go to the moon to help save our civilization here with new technologies, new approaches that can be fed back into the terrestrial science and engineering communities for us to be able to make the move forward. A little bit about lunar industrialization. This is a design I did for NASA in 2006. These are what's called power towers. Each one of these are 100 kilowatts. And I just talked to IEEE today, and we're going to be making a very concerted effort to work with the professional societies, IEEE, ASME, ASCE, I'm a concrete canoe guy, in college, to develop standards for lunar surface systems operations and the things that we need to operate on the moon. Power, so there's a power, the 100 kilowatt power towers, adding capability with swarm robotics, metals processing, forging, pouring, all of the things that we've done to industrialize the earth, different and versatile robotics, gantry chlorines, all the stuff we use here on the earth, we translate it for use on the moon for an industrial development. High mobility rovers or other things. So a lot of the stuff that originated here with self-driving cars is going to have direct application for the moon. So 3D printing, everybody knows what that's doing now, the metals printing. And just think if you have a 10 to the minus 12 torr vacuum to where you don't have the contamination problems that you have here in any of your vacuum manufacturing on Earth, that's the kind of quality vacuum we're going to have on the moon to do a lot of stuff. Laser sintering. So this is kind of what it might look like. We're pouring metal, and one of the things that we're working with CES Group at, we're doing a thing called the Frontier Development Labs, and one of our projects, it's being hosted by SETI this summer, is that we're looking for metal meteorites. Three or four out of every 100 of those holes on the moon were done by a metal meteorite. And we're looking for these material resources to jumpstart lunar industrialization, and these are some of the fun things that we do with our friends at SETI and here at NASA Ames in Silicon Valley. Thank you very much.
Thanks very much, Dennis. Always fun to hear you talk.